Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
So here for part A, we know that a small segment of the rope has mass and is being pulled down by the gravitational force of the Earth. So we can say that rope has mass and therefore has gravitational force. Given this, we know that equilibrium is reached because neighboring portions of the rope pull sufficiently up on it. So because tension is a force along the rope, we can then say that here at least one of the neighboring portions must slope away from the segment that we are considering. So because the tension force is an upwards force, or rather has an upwards component, we can then say, of course, the rope will sag. For part B, we can then say that the only force acting with a horizontal component is the applied force. So treating the block and the rope as a single object, we can write Newton's second law. And we can say that F is equaling the mass plus m times a. So this would be the sum of the mass of the block and the rope times the acceleration. Therefore, the acceleration is simply going to be equal to the x component of the applied force. We can say applied x divided by that mass, that sum of masses. And that would be the formula for the acceleration. For part C, we can then say the force of the rope Fr is the only force with a horizontal component acting on the block. So then we can apply Newton's second law for only the block, and we can say that the force of the rope would equal the mass of the block times the acceleration, and this would be equal to the mass of the block times F. F, essentially, to avoid confusion, we can just call this F. So the F that we calculated, rather that was given in part B, and then divided by the total mass of the system, we're essentially just plugging in for the acceleration that we have found in part B. And so we can say that, again, the force of the rope would simply be equal to mf over m plus m. And finally, for part D, we can treat the block and half the rope as a single object. So here we can say m plus 1/2 m would be the total mass, where we have where the horizontal force on the block and half the rope would be T sub m. T sub m we would be considered the midpoint, the tension at the midpoint of the rope. So we can say that the tension at the midpoint of the rope would be equal to m plus 1/2 m times the acceleration, and then we can plug in. So D would be equal, for part D, T sub m would be equal to m plus m over 2 times F divided by the total mass. And we can simplify. So this would be F times 2m plus m divided by 2 times m plus m. This would be our tension at the midpoint of the rope. That is the end of the solution. Thank you for watching.